SharePoint and Office apps both rely on OAuth, which is the Open Authentication Standard. And there are two modes that we can use when we're working with apps that are cloud-hosted, either auto-hosted or provider-hosted. The first one is a high-trust model. And this one is only available in a provider-hosted model. But what this means is that the app is trusted to assert any user's identity and that the app itself acts as an identity provider. So it can say, I'm going to talk to the SharePoint site right now and I am user X without having to provide the credentials for user X. The second mode is called low trust. And in low trust, which is how auto-hosted Azure apps work and Office 365, the app has a specific identity that's provided by some other trusted provider. In the case of Office 365, this is the Azure Access Control System. Office 365 is always low trust, but you can run low trust locally as well by using the Windows Azure ACS for Active Directory. On-premises can be either depending on your configuration. Now, the key thing to understand about this is that an app still has permissions. So although in a high trust scenario the app can say, I am this user who may be an administrator, the app itself still has a set of permissions, and it gets the permissions of the app, not the permissions of the administrator. So there is still a box there. So high trust does not necessarily mean the app can do anything. High trust simply means that the app is allowed to pretend to be any user in the directory system. So what we're going to do now is start working on a new high trust app. Now this requires a decent amount of setup to be done ahead of time. I have already done it. The documentation is all available to you on TechNet. All right, so let's get started with that. All right, so we're going to make a new provider-hosted app that is going to run in a high trust mode. So I'm going to go to File, New, Project. And this is once again going to be an app for SharePoint 2013, and we'll call this High Trust. And I will choose OK. Now this time, instead of it being SharePoint hosted, I'm going to select Provider Hosted and hit Next. And when I do, it's going to ask me for some information. Now I've already set this up ahead of time. For high trust, I need to create an identity provider for the app which is based on a cryptographic key. And so I have a certificate which I've already created and installed, which is in my C drive under the certs folder called hightrust.pfx. And I have to provide the password for that. And then the other piece I need is an issuer ID, which is a GUID that I created when I set up the trust mode. So if I don't have this correct, even though the certificate is the same, the identity is not going to be recognized as something with permission when I go to install the app. So when you set your environment up, make sure that you store this. It's good that Visual Studio remembers what your last issuer ID was, but if you forget it, you're going to have to run through the PowerShell scripts in order to set the environment up a second time. All right, so I'm going to click Finish. And Visual Studio is going to create a high trust web project for me. Now this is not a SharePoint web. This is actually going to be a website that is going to run in IIS, and in this case inside of IIS Express for Visual Studio. So we'll start off with our little form here, and I'll just put some text in here to say hello. And if we look, you can see that this time there are no features or anything like that inside of the High Trust web because this is not a SharePoint project. This is a traditional ASP.NET website. There is some additional web config that is necessary to make this all work that Visual Studio takes care of for us in a development scenario. And there's also this file called Token Helper CS. And Token Helper CS is all of the code that is necessary to parse out the information that is in the cryptographic key that is used to secure the communication between SharePoint and the provider-hosted application. And this just comes for you out of the box. It's already generated. It is good to take the time to understand what's in here because you can learn more about the application infrastructure, but it is not necessary to get started. You can just take it as it is. All right, so the second project in here is the actual app. And so this has a PNG that gave us as the icon. We can provide our own icon if we want. And it also has the app manifest file. And this is the same type of file that we would get whether we were using SharePoint hosted, auto-hosted, or in this case, provider hosted. And so it specifies what the start page is going to be. In this case, it's a page in my HITRUST web called default ASPX, and it's going to pass the standard tokens to it. I can also specify permissions. I can specify prerequisites. I can do multilingual scenarios. And if my app is going to need to call some remote endpoints, I can set these up, and SharePoint will act as a proxy for me to make sure that my communications with whatever those remote endpoints are nice and secure. All right, so let's go ahead and start this. And it's going to install the app for SharePoint. And then ask me if I trust it. So this is part of the setup. I'm going to say that I'm going to let it access basic information about the site and basic information about the users of this site. I haven't specified any other permissions beyond that, and that's fine because at the moment the page doesn't have anything on it. When I click Trust It, we actually get redirected in my development environment over to IIS Express. And so this is running under localhost, a port that was assigned by Visual Studio, and there's pages default.aspx. And the key thing here is that this is not part of SharePoint. This is external to SharePoint on its own IIS website. The app manifest defines the permissions that the app will request. And there are a lot of different scopes that are available to you for permission sets. So you can scope to the tenant, to the web, to the list, and lots more. Search, site, you'll see some of these in just a second. And then within the scope, you can request a number of potential rights that your app is going to require. You can ask for read rights, you can ask for write rights, you can ask for manage rights, and you can ask for full control rights. Now there is a problem with the on-premises version at the moment, which is that the documentation for what these rights are does not match the reality. This is a change from the beta, and so I assume that this is a bug in the released version that will be fixed as a result of a hotfix soon enough. But this more or less tracks as documented to the normal sets of users permission in a regular SharePoint site. So read is read-only, write means they can add items to lists and libraries, manage means that they can apply themes and mess around with the master page and do some permissioning stuff, and full control means that the app is going to have full control. Often with provider-hosted apps running in a high trust mode, it makes good sense to ask for full control. And the reason for that is because you can assert the identity of any user, and you're going to have the rights of that user. So with a HITRUST app running under full control, if it is acting on the behalf of the current logged in user, which is normal, the app is going to have exactly the same rights as the user. But if you need to elevate in order to do some sort of administrative thing, you can create a reserved administrator account for that app and then assume its identity for those operations. There are also a whole set of service-specific rights. For example, for search, there's one called Query as User, Ignore the App Principle. And what that means is that when the app issues a search query, it's going to run as the user and completely ignore the fact that it's being issued by an app at all, so that security trimming works for the user instead of for the app. All right, so what we're going to do now is go back over to our HITRUST app, and we're going to set some permissions, and then we're going to add a little bit of code to manipulate the host web. All right, so let's take a look at the code behind for the default page. Now, I already added that little hello prompt in there. What we're going to do is actually look at the CS file. And this is all provided for us out of the box. And what this does is it reads the SP host URL off of the query string. That's what the standard tokens are all about. And then it uses that in conjunction with the token helper to get the server-to-server client context with Windows identity. And in the sample code, what it is doing is using the request login user identity. What this means is that whenever you hit default.aspx inside of this app, it is going to use the same identity of the user that is logged into the SharePoint site. And so this is going to have, at most, as this process runs, the same level of permissions that the user has. All right. What we're going to do now, though, is modify the code in here a little bit to let it mess around with the host web. I have a few apps that I've built, and I have an entire provisioning library that is all based on the client-side object model. So it is possible, and not in fact very difficult, to create fields and content types and web part pages and list views and all of the stuff that a normal SharePoint business application is based on. But that's quite a bit more complicated than what I'm going to show you today and would take quite a bit of time to explain. But just trust me that it is possible and not too terribly difficult. So we're going to come over to the Permissions tab inside of our app manifest, and I'm going to say that I want full control over the host web. What I'm going to do here, I should be able to do with manage permissions as documented, but at the moment that will fail, and I need to use full control in order to make it happen. So I'm going to come back over to default ASPX, and right now what it's doing is getting the web title and writing it out as part of the response stream. So before this part, what I'm going to do is just add a little bit of additional code. And what I'm going to do is I'm going to set the host web's title. So I'm going to say that I want to get the client context and its web. I'm going to take its title, and I'm going to set it equal to the title, plus date time now. Now, it's always a lot of fun to type code while you're talking and explaining, and I already made a mistake here. And the mistake is where I put this line of code. Because I'm going to read the web title, I need to do it after I have loaded the web. So I'm going to take this line of code and I'm going to move it underneath the execute query. All right, because what this first line of code that they gave us out of the box says is load the title of the client context web. So after execute query runs, which is synchronous in this case because this is not JavaScript, I will be able to read the web title. If I had it above there, I would get a runtime error telling me that the property hadn't been initialized. All right, so we've changed the title, and now we just need to call clientcontext.web.update. And in order for this to happen and for it to be saved, we need to execute another query. Right? So everywhere you see execute query in C# or execute query async, a web service call is going to be made, which is going to run based on whatever happened before it. So in this case, it says load up the web title, and in this case, what it's saying is update the title to some other value. All right, and then we will write that out to the response stream onto the page. All right, so let's start this up. And we will say we do trust it. And now it's writing out developer 18 blah, 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 blah. And if we come over to the developer site itself, we can see that we did, in fact, edit the title of that app. And every time this page runs, it's going to continue to update the title of the app with the current timestamp. By now, you should be coming to grips with the fact that you have a lot of choices with regards to how you build your user interface. Now, just because you have an auto-hosted component to your app or a provider-hosted component to your app does not necessarily mean that the user interface has to be there. It's possible for your app to actually manipulate the host web and add the user interface to it. Or it's possible to have a SharePoint-hosted component which is backed up by your auto-hosted or provider-hosted app. But the reason you would have those websites in these cases would be to handle things that you need to do that would not really work well in JavaScript. In other words, places where you need server-side code. And for that, we have remote event receivers. So what a remote event receiver is a web service notification to the hosted app of host web events. And there are a whole bunch of different events that you can subscribe to. If you're familiar with eventing in Farm Solutions and Sandbox Solutions, you'll be pleasantly surprised to discover that there are a lot more events that you can listen to. So you can see when the app is installed and take action then. You can see when a group is added, when a site gets created, when an item is added to a list, and a whole bunch of other stuff as well. And this is based on web services. So when you add a remote event receiver, either through Camel or through code, what SharePoint is going to do is call that web service with the notification that it happened. And what's on the other end of that web service could be anything that you want it to be. It could be ASP.NET, which is what I'm using in my demonstrations, but it could be FastCGI or Ruby on Rails or something that I've never heard of. As long as it can respond to HTTP requests, it can receive notification about the remote event being fired. All right, so what we're going to do now is take a look at our HITRUST app, and we're going to add an event handler to it to handle the app installed event. All right, so here we are in a HITRUST app, and what I would like to do is run some code whenever this app is installed. And Visual Studio 2012 makes this very easy for me to set up. I just need to select the HITRUST node, or rather the project, and here on the Properties pane, there is a property called Handle App Installed. So I'm going to change this to true. And when I did that, it added a service endpoint to my provider-hosted web called app-event-receiver.svc. And in the CS file for that, it's already got all of the kind of fun wire-up code that I need to establish the trusted context using the token helper and all of the other stuff that's there. So what I'm going to do is I'm going to take the contents of this page where I was setting the title of the web, and I'm going to just copy this out of here, or cut it rather. And I'm going to come over to the app event receiver, and I'm going to manipulate the title, except this time instead of using the title itself, I'm just going to change the title itself to be set by remote event receiver. Now this time I don't have to do any sort of reading of the title ahead of time because I can always assign properties in CSOM without having loaded them from the server. It's just when I try to read them that I have to have initialized it. So I'm going to go ahead and set a breakpoint in here just to show you just how easy this is, and we'll start this up. And we'll trust the app. And now we can see it installing. And now it is called our remote event receiver to handle the app installed event. So we'll just continue. And now the default page says that the title is set by the remote event receiver. So it would be totally possible for me to have this page actually redirect you back to the host web if I didn't want any particular handlers. I have a lot of choice with regards to how I set this up. All right, so let's close this, and I'm not going to write any more event receivers, but I'll show you some of the model, how you add them in. I'm just going to right-click the app, not the host web, and I'm going to go to Add and choose New Item, and then we have a choice here for Remote Event Receiver, and we'll just let this be called Remote Event Receiver 1, and I'll choose Add. And it gives me categories of the different kinds of events that I can add. But there's a little problem with this user interface as it exists in the moment, and that's it does not show all of the events that are available. So if I open up the XML file, we can use the schema to actually see all of the stuff that's available to us here. So you can see we can pick up that fields are adding and deleting, things that happen to sites, that the site's been deleted, that the web has been added, things related to groups and users, and role definitions, and workflows, and all sorts of stuff that's not available to us on that little starter wizard at the moment. So lots and lots of remote events that we can handle. And the web service signature is going to be the same regardless of what these are. So it's not that big of a hindrance to me that the wizard doesn't have it. I can put those in, and then when I come over to the actual code, the argument that I always get is going to be the SP remote event properties, and it's going to have the information that I need in order to respond and know what event happened, and what I need to do once it's happened is up to me. So when I first heard about the app model and remote event receivers and all of this new stuff, my first thought was, I wonder if it's any good. If you are a fan of these videos, you remember, I hope, that back in the 2010 cycle, we had this thing called Sandbox Solutions, and I built a reference application for myself in order to decide, is it any good or not? Well, I was working on a product that was based on Sandbox when I found out about apps, and so I got the opportunity to rewrite that product using the app model. And I'm going to show you just a little bit of it now. The thing about an exploring course is I can't spend hours and hours talking about code in loving detail, so I just want to give you an idea of the possible. The moral of the story is I think that apps are very worthy and that you can build traditional style SharePoint applications. And so what we have here is an application that is based on web part pages and list views and menus and site columns and content types and all that good stuff. And it's got all sorts of JavaScript running, and none of the stuff that you see that's going on right now while I'm clicking on the screen is based on server-side code. This is all done with JavaScript. And there's fun UI behaviors like little type ahead widgets that I can use, and jQuery UI calendars, just all kinds of wonderful stuff. And so the moral is, like I said, that this is totally doable, and I think I can endorse this as a viable model. Now, the thing about this is this is all done with client-side APIs and remote event handlers, and so there's no feature XML or any of that stuff. I'm actually taking the host web and injecting content into it. And so here I have an app event receiver, and what it does when the application is installed is it creates all the fields, then it creates all the content types, then it creates all the list instances, then all the files, and these are web part pages, and then it provisions some custom actions. And the code for this is over here. So the way I create fields is I have XML definitions of them, and I loop through all of those using the client object model. So the first thing that I need to do is get all of the existing fields, and then if the field doesn't exist already, then I add the field as XML. Now, the thing that I want to show here, and then I want you to get your head around it before you start using the client object model, is that it's very batch oriented. So I get all of the existing fields as an entire batch of operations. I say I want to get the fields, give me their field name, their static name, and then I execute a query. And then once I've executed that query, I go through the process of queuing up every single field that I want to create, and then I execute another query. Once the fields are made, I'm ready to do the content types. And that's done in a very similar way. So I have a sort of interface-driven design here, and each one of these contains a list of fields that are going to be included, and a parent content type, and the group that they're going to go in, and a description, all of the things that you would see if you were working in XML, except now we're working procedurally. And much like the fields, this goes through the process of first getting all of the existing content types, because I'm going to need them for parents, and then getting the parent content types that I'm going to need. And then it creates each one of the content types, and then it adds all the fields to them. And this is once again done in a batch process. And so if I were to take you through each one of these provisioning operations, they all follow the same idea, which is that there is a layered set of provisioning going on. So for the files, first I have to create the files, then I have to set their properties, then I have to add the web parts to them. For lists, first I create the list, then I bind all the web parts, then I create all the views. Once you get your head around that, you'll find that the client object model is pretty straightforward to use. And at the end of the day, you will be able to create nifty traditional SharePoint-style applications using the app model. It's totally possible, and you don't have to give up any functionality from the farm to do it, at least as far as the user interface is concerned. SharePoint 2013 provides 3 major client-side APIs, all of which existed in SharePoint 2010, but all of which have had significant expansion in 2013. So the first is the client-side object model, which comes in a managed code and a Silverlight flavor. And that is if you'd like to write your code in C# or VB.NET. You can use the client object model in apps. You can use it also in other systems that need to attach to SharePoint if they are written in .NET. The next is the JavaScript object model. The JavaScript object model can do all of the things that the client-side object model can do, plus it contains a number of other APIs that are used for user interface type things. For example, there is a dialog framework that is built into the JavaScript object model. There is also a thing called scripts on demand and various other aspects that are in the JSON object model that don't make sense in the client-side object model. And then finally, there is a REST API. Now, the REST API has been redone for SharePoint 2013. It uses a different service endpoint on the server now, and it is quite a bit more complete. The REST API is the one that has the broadest reach because it can be dealt with via anything that can issue HTTP requests and response. The JavaScript object model is probably a close second because just about everything understands JavaScript these days. There is even a JavaScript package or a JavaScript object model package for Node.js. But a lot of people who are building phone applications, maybe on iPhone or Android, may find that the REST API is the one that's for them. Now, the REST API has a few flaws. Some people say that it's not a very good implementation according to RESTful principles, and there are some things that they expect to be there via the OData specification that are not quite there. So it's a little quirky, but it's pretty powerful just the same. All right, so we're going to jump over to a server right now and take a really short look at the REST API. All right, so let's take a look at our dev site here. Actually, I'm going to open this up using Chrome just so I have the benefit of a little bigger address bar. And we're going to go to SharePoint dev site that we've been using all along. Now, the REST API is addressable from your site followed by _API and then the thing that you want to look at. So if we're interested in the web here, we could just go API web, and SharePoint responds with all sorts of information about our web. And these different things that we see here give us the ability to navigate further down, to set properties, and do all sorts of things. Like I said, this API is just as big as the client-side object model in most respects, and you can do a lot of stuff in it. So if we do a little search in here, I know this isn't the easiest thing to read. If we look for lists, we can see that there is an href for the list collection. So we can use this to see that we could go down into the lists to further navigate. And here we can see all of the different list titles that are there, different folder titles, and each one of these we can get to via a further URL. So say, let's see, we are on the dev site right now. So say we're interested in, whoops, that's not a list. Say we are interested in the notebook list. Let's use documents. All right. So if we come over here, and search for documents, here's the element for it. And we can follow the URL. And get information about the documents list, what its role assignments are, what its content types are. All of the things that we can navigate via the normal object model can be done through the REST APIs. JavaScript is not just for apps. There are a lot of scenarios where you will use JavaScript in the context of farm and sandbox solutions. And so I don't want you to get the idea that the JavaScript object model is something that you can simply ignore if you're not building apps. In SharePoint 2013, pretty much all of the rendering has moved to JavaScript because XSLT is so 2003. So the emphasis is now on JavaScript. The old web parts that used XSLT are still there and they still work so that you can upgrade your sites to 2013. But now, if you take a look at a list view web part, you will discover that it is, in fact, being rendered by JavaScript. Lots of members of the object model have a property called JSLink. And you'll find JSLink on fields and content types and views and on list view web parts and in some other places as well. And what the JSLink property does is allow you to tell SharePoint to invoke a JavaScript file when it decides to render that element. So it gives you the ability to completely take over the rendering of your HTML from SharePoint simply by intercepting the JavaScript call that does the rendering by default. Good places to look at this are in search and in the hover panel. So all of the hover panels that you see in document libraries and lists that you hover over are based on JavaScript. The list views themselves are based on JavaScript. And the search result panels, web parts, and hover panels are all based on client rendering. All right, so let's jump over to a SharePoint site and take a look at client rendering and see what it is all about. So the first thing that I want you to understand with regards to client rendering is that by default, that's what happens out of the box is JavaScript-based rendering. So we're looking at a team site in Firefox. I'm using Firefox for this demonstration because I like the JavaScript debugger that comes in Firebug. And in this particular page, we have a list view. Now, I've done a little bit of setup here, which is intended to force SharePoint to serve up the debug versions of the JavaScript files. And so I have edited the web config file, and I've set debug to true under compilation. And once I do this and save the web config file, instead of getting minified versions of all the JavaScript files, I get debug versions of them, which makes it a lot easier to read what is happening. All right, so I also have the page open up in Firebug, and I've started the script debugger. And what we're looking at here is a JavaScript file called clienttemplates.debug.js. And this is the file that contains the JavaScript rendering of the default list view stuff, right? So we have a function to render the view, the header, the body, the footer, the groups, individual items, individual fields, and fields by name. And these are the things that you override for individual elements when you specify the JS link. All right, so over here in Internet Explorer, since I've got a debugger going on over on the other one, if we open up this same page and edit it, and come over and edit the document's web part, we can see that down here at the bottom, under the miscellaneous section, is JSLink. And if I don't override this, then it is going to call the JavaScript file. Now you can see also through these properties that I can force it to render on the server. I can still use XSL if I want to, but out of the box, by default, new list view web parts are rendered by JavaScript. All right, so if we come over here back to Firefox and refresh this page, it's going to hit that breakpoint that I set inside of Firebug. Now, you can see where we are in the page rendering lifecycle, right? There's the heading for the document's list view. And we have made it to right here where render core is. And we can see that this has been called from the render list view function, render core. And this is going to be passed through a few times in order to render the different list views on our page. So we'll just disable this and run it. What I want you to take away from this is that the client templates debug file has examples of client-side rendering, and it's much better than what you'll find in the SDK. So this is a great place to start if you're interested in writing your own client rendering. Now the other place that we see client rendering is in display templates. And so what a display template is the JavaScript that renders this thing right here that we're looking at. And those rendering templates, let's see if over here in Internet Explorer, if I can get the Office Web Apps to, oh, there we go, just a little hiccup from Firefox. But this is all being controlled by JavaScript. And if I'm using a publishing site, it will generate the JavaScript for me from HTML that I can mark up. This is not a publishing site. And so to see the rendering templates, I'm going to open up SharePoint Designer 2013. And I'm going to go to All Files, and I'm just going to navigate down into Catalog, Master Page, Display Template, Search. And in here, there is the common rendering panel. And so what I'm going to do is find Item Common Hover Panel Body. And I'm going to edit this file. We'll give ourselves a little bit more screen real estate here. So as you can see, there's a lot going on inside of this file, but a lot of what it's doing is just spitting out HTML. All right, so all these blocks are determining what HTML it wants to spit out, and then it's spitting out. So this line right here, line 97, is the line that is the title of the document. And so what I'm going to do, just for the purposes of demonstration in this div, is I'm going to add a style declaration. And we'll just say color is going to be red. Make it nice and easy to spot. All right, so now if we come over here and refresh the page, well, wait a second. Let's do a search. There we go, as I was changing the one for search. Right, so changed by administrator on blah, 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 blah. Turned it to red. So I can create my own display templates, I can override client rendering, and I can do that all with JavaScript. So XSLT is a thing of the past for new SharePoint 2013 development endeavors.